Bowen from Advanced Diver Magazine and RebreatherWorld.com. Today we're talking with Richard Pyle. Richard, tell us a little about what you got.
Well, as it says, my name's Richard Pyle. I work at Bishop Museum. I'm actually a scientist, but I've been working with Poseidon to develop this new rebreather, the Poseidon Mark VI Discovery. So this is the mouthpiece on the Discovery. It's got a couple of features worth mentioning. One of them is that it's got a built-in open circuit bailout regulator. And this lever here switches between the positions. Right now it's in open circuit mode. Flip it up, it's in closed circuit mode. Another interesting feature is that the open circuit regulator, when in closed circuit mode, doubles as a ADV, an automatic diluent valve. The triggering pressure is higher when it's in closed circuit mode, so that it doesn't give you a little breath of air every breath you take. It only gives you a breath of air when you bottom out the counter lungs to replace the gas that you need to make up the volume in your loop. But then when you're in open circuit mode, it breathes just like any other open circuit regulator. It's also got a heads-up display here. So the heads-up display has several features in it. One of them, of course, is an red LED light, which is used for warning a diver that there's a problem. There's also a vibrator in here, the Kevin Jurgensen Diva system, that vibrates if there's a problem. And there's also a sensor in here that detects the position of the mouthpiece. So the system, the electronics know which position you've got the mouthpiece in, whether it be closed circuit mode, open circuit mode, or unknown mode. And if it's in the middle, it actually knows that it's not sure which position it's in. So that allows the alarm systems to work in concert with this. The breathing hoses come out of the bottom part of the regulator like this. They attach with these simple, very standard connectors here that just thread right off with an O-ring seal on them, and there's the check valve. And you just plug that on and thread it in. And your inhale breath comes from the left-hand side, and then your exhale breath goes out the right side. So after your exhale breath leaves the mouthpiece, it goes through this hose to what we call a water diverter. This actually has a shape inside of it that encourages any water that might get into the system to go into the counterlung rather than back into the system. So this is the exhale counterlung. When you exhale your breath, this is where your breath initially goes, into this counterlung. As your lungs collapse, this counterlung expands like a flexible bag. And then when you inhale, the gas moves through the loop, pulling it through the counterlung and through the back of the system. So on this exhalation counterlung, there's an overpressure relief valve here at the bottom. So if the system gets too full, this is where the extra gas burps out of the system. It's adjustable, so you can have it a low back pressure or high back pressure. It's also useful in that this is where, if water does get in the system, this is where most of the water collects. So having this valve down here at the bottom of this counterlung allows you to dump the water out of the system if you want during the dive. After it passes this counterlung, it follows through this hose back into the gas processing unit, which includes the carbon dioxide scrubber and the electronic system. So after the gas leaves the exhale counterlung, it comes through this hose right here and enters this. This is the carbon dioxide absorbent canister. So inside of this housing here is a pre-packed canister with soft-lime absorbent material. It's a special chemical that will absorb carbon dioxide chemically and pull it out of the system. So as a diver exhales, and the exhaled breath has carbon dioxide that the diver exhaled, that gas passes through this canister and all the carbon dioxide is removed from that breath chemically by this absorbent canister. What Poseidon has done is they've made a pre-packed canister. That is, the canister comes from Molecular Products already ready to insert in this rebreather, already pre-packed. So it removes one of the normal maintenance steps of rebreathers. You don't have to pack the canister anymore, it's already pre-packed. You stick it in here and seal it up, and it seats on an O-ring and it's ready to go. So the main key issue, though, is that this is the part of the rebreather where the carbon dioxide is removed from the diver's exhaled breath. So after the exhaled gas comes through the carbon dioxide absorbent canister and it's filtered and removed the carbon dioxide, that gas enters this chamber up here. This chamber right here is the oxygen sensor chamber and the electronics chamber. So this is the electronics module that sits right on top here. And this piece right here is a battery which pops out, and you can see that it's just a self-contained module. You can take it back and recharge it. It's got a rechargeable battery. The battery is good for about 30 hours of dive time. Inside this battery, it's actually a smart battery, which tracks its own life very, very accurately. So it's got an accurate prediction of how much battery life you have left. It's got a speaker in it to give you an audio signal if there's an alarm. It's got 2 bright red LED lights back here that flash and let your buddy know that there may be a problem, if there's a problem. And it's also got a data download log built into it so that your dive log data remain inside this battery. And once you've recharged it and you're ready to dive, you just stick it in here and just stick it in like that, and it's ready to go. So right next to this battery right here is this gas processing module. It's a pneumatics module. It handles all the gas injection to the breathing loop. So I'll pop this module out here, and there are 2 gas supplies to this. One is oxygen, one is air, or whatever your diluent is. And those gases get up into 4 different solenoid valves, small little solenoid valves that are built into this module. Now, each of those solenoid valves has a very specific purpose. 2 of them deal with the same way that most rebreathers have a valve, which is to inject oxygen to make up what the diver consumes while breathing the gas mixture. And the reason there's 2 of them is so that they can alternate A and B, and you have a little bit of redundancy in there so that you have 2 different ways of replacing the diver's metabolic oxygen. Now, but the other 2 solenoids are what are kind of interesting. One of them is for the air, one of them is for the oxygen. And both of them direct their gas straight on the oxygen sensor inside here, this one right here. This is called the primary oxygen sensor. You'll notice there are only 2 oxygen sensors. Most rebreathers have 3. This one only has 2, and it's an entirely different approach to how we track the PO2 in the breathing loop. Basically what we do is we have one oxygen sensor that we're absolutely confident in, and then we have a second basically serving as a backup. And the way you have absolute confidence in an oxygen sensor is that every 5 minutes you inject a little bit of gas on it from here during the dive and watch the sensor response. So if you know what the gas concentration is and you know your current depth, you know how this sensor should respond very precisely. And so what the system does is it monitors that response and makes sure that the sensor not only can register the right amount of gas at whatever depth you're at, but that it is responding in the way that you would expect it to. So if, for example, if it had condensation on it, or if the sensor started to go bad during a dive, this test would be able to pick that up very, very easily. And as an added bonus, once you've got this system in place where you've got this module here connected straight into the oxygen sensor chamber, you can also do automatic calibration. It'll calibrate the oxygen sensors automatically every time you power up the system, and it only requires a small amount of gas to do that. So just like almost any other rebreather, at least any closed circuit rebreather, there are 2 gas supply cylinders. One of them here contains oxygen, the green one on the right, and the black one on the left contains a diluent gas mixture, which is typically air. So the gas supplies feed into this pneumatics block right here, and this is where the pneumatics blocks get its various gases to inject into the system. Now, one of the things this system does during initial pre-dive is it validates that this really is oxygen and this really is air. So part of the process is making sure that the gas that's injected is really the gas that you connected to. That greatly reduces the chances that you'll accidentally hook the wrong cylinder gas supply up to the wrong regulator. So these are Poseidon first stage regulators, and they've got electronic high pressure sensors on them which feed the gas pressures into the electronics, so the electronics always know how much of each gas you've got left in it. The other thing that the diluent regulator has is a hose here coming out of it that feeds your open circuit bailout regulator. Now, this gas supply, your onboard diluent gas supply, is only good for bailouts from very shallow depths. So the system assumes that if you're going deep, you're going to have another gas supply with you that allows you to make a bailout. But even still, it calculates how much gas is left inside the diluent cylinder and makes sure that it's enough, in worst case scenario, for a diver to get from the current depth up to the surface safely. This assumes no decompression, of course, but it will warn you when this onboard gas cylinder has too little diluent left to safely make it to the surface, whether or not you've got an external gas cylinder. So this is the primary display system, LCD display system. On the back are these 2 wet switch terminals, which if you touch them, power the system up. Now, to prevent false starts, it wants to make sure that that you really mean to turn it on. So there's a certain procedure where you have to touch it, release it, and touch it again, and hold it long enough to actually go into pre-dive mode. Now this is on a normal startup when you're actually intending to start up the rig. Alternatively, if you were to jump in the water accidentally without going through the pre-dive, it would of course kick into dive mode immediately and do everything in its power to keep you alive and healthy. So what it's doing right now is it's running through a series of pre-dive tests. You see this little letter T here and a number, and it's running through a whole battery of different tests. The first 27 of those tests or so are internal tests that monitor whether or not the solenoid valves are actually pulling electricity, whether the alarm systems are pulling electricity. It's sort of a way of making sure that the mechanics of the LEDs and the speakers and the solenoids are actually working, because if they're not, it won't detect power draw when it tries to turn them on. So it's doing a lot of internal diagnostic tests right here. As it goes through the tests, it runs through a different series of other tests. It makes sure that the mouthpiece position can be detected both in open circuit and closed circuit. It makes sure that there's gas in the cylinders. It runs a check on the positive pressure loop test so that it fills the loop up. It has a depth sensor inside the breathing loop so it can detect whether or not there's pressure in the system and whether or not it can hold that pressure, so it does an automatic loop test. Also, that test is important because it verifies that the oxygen solenoids and the diluent solenoids are actually injecting gas. So if you've left your cylinder off or if there's a blockage in the regulator, it will fail that test. Because in addition to all the other tests it runs, it also does the oxygen sensor calibration and makes sure that both oxygen sensors fall within the right calibration range. And it does a couple of other tests after that. It prompts you to switch the mouthpiece to open circuit position to make sure it can see that. It wants you to test the open circuit mouthpiece to make sure it actually, that you actually make sure it functions. And once it's done with all the pre-dive tests, which take about 2 minutes or so, 2.5 minutes, it's ready to dive. So right now it's in ready to dive mode. This big number up here is your current PO2. If you watch it for a while, it'll cycle and tell you what position the mouthpiece is in. You'll see it says OC, meaning open circuit. It'll also tell you your set point. The big number down here, which is now 0, is depth. That tells you your current depth. This big number over here, 199, tells you your remaining dive time. That number takes into account decompression status, remaining oxygen supply, remaining battery supply, and various other factors. So it's one number that says whatever your limiting resource is, this is how many minutes that resource has left. Very simple number. The little number below it tells you your elapsed dive time. Just like over here, this little number here tells you your maximum depth. And of course, the water temperature. This area up here that's all blank right now is reserved for alarm icons. So if anything goes wrong, those icons show up here and they give you instruction on what to do. After the gas is processed by the backpack and passes through the electronic oxygen sensors, it comes up this hose right here and into this water diverter here. Same idea as this water diverter. It diverts the water into the counter lung if any gets into the system. There's an extra port down here in case you wanted to add some other feature, either another dump valve or a manual gas addition valve or something like that. And then after this inhalation counter lung, the gas passes through this hose and into the mouthpiece where the diver breathes it again.
Thank you, Richard, for coming out today
Thank
and
you,
showing
Curt.
us all about your rebreather.
Sure.
I'm Curt Bowen at Advanced Diver Magazine, rebreatherworld.com.